Okay, let's take a look at your 6.6 part 2 assignment here. We're continuing on with our linear programming problem. So again, let's read the problem, define our variables, objective function, and continue the process of solving the problem. So it says your band is playing a concert at Hopkins High School Auditorium. You will sell at most 400 tickets to students and at most 200 students or tickets to the general public. It costs 50 cents per ticket to advertise the concert to the students and $1 per ticket to advertise to the general public. You have been given an advertising budget of $300 for the show. You have decided to charge $4 for a student ticket and $7 general admission ticket. Determine the number of general admission tickets and student tickets you should sell in order to maximize your income. Well, again, can't emphasize enough the last sentence. In the vast majority of these problems tell you how to define your variables. So we're going to let X equal the number of student tickets and we're going to let Y equal the number of general admission tickets. And in this case, since it says maximize your income, just to be different, I'm going to let I equal income. But if you did P for profit, we probably wouldn't get too uptight about it. So now, our objective. Sorry, the pen's doing a little funky there, objective function. So, how do we make the money? Well, how much are we charging for the tickets? Right there. So, our max income will be 4x plus 7y. So now, we also have to deal with the constraints. So this one is a little bit different. We know that x has to be greater than or equal to 0 and y has to be greater than or equal to 0 because you can't sell negative tickets. But we actually have a limit on how many of each tickets that we can sell. You can only sell a matter of 400 student tickets and 200 general admission tickets. So x has to be less than or equal to 400 and y has to be less than or equal to 200. The last constraint deals with your advertising budget. You have a maximum of $300 in advertising to work with. You have $1 that you can do on a general admission ticket and 50 cents for the student tickets. So we know that 0.50x plus 1y has to be less than or equal to, in this case, 300. So now we want to graph these. What makes these a little bit different to graph is you have actually this x and y. So you actually have some horizontal and vertical lines to deal with. So these aren't actually really hard to graph. I'm going to come to it in just a second. I'm going to deal with this one here first. If I let x equal 0, what's nice is this disappears. 1 goes into 300 times. If I let y equal 0, 0.5 goes into 300 600 times. So I can go ahead and graph that point. What's nice about our graph is, for some reason, this one's already scaled for us and labeled, which makes life a little bit easier. So I can go ahead and graph that inequality. Now, according to the first two constraints, y has to be greater than 0, x has to be greater than 0. So right now, my feasible region is this triangle. However, I still have two more constraints to deal with. I have this one right here. X has to be less than or equal to 400. So I go over on the x-axis to 400. X equals 400 is a vertical line So I need all the values that are less than it. Notice how this chunk of the triangle is no longer part of a solution. Likewise, when I graph this one right here, y equals 200, I get a horizontal line at 200, and it has to be less than that. Cuts off that little piece of the triangle. Now, all of a sudden, here's my feasible region. So now, I need to find my corner points. So now, when I find my corner points, here we go. 1, 2, 3, 4, 5 of them. 3 of them, pretty easy to see. And really, we might find the other ones either using matrices or even by hand, because this graph is a lot easier to work with. So let's get the first couple. We know that 0, 0 is a point. We know that 0, 200 is a point. We know that 400, 0 is a point. Now we need to find these other ones. Now what makes these other ones a little bit easier here is I know right now that this point x is 400. I know that because it's intersecting the line x equals 400. So a lot of times what I'm going to do is I'm just going to take 400, plug it in here. Half of 400 is, because 50 cents times 400 is 200. If I subtract that from 300, I get 100, so 1y equals 300. Notice how it's at 100. So that works. Do the same thing for the other one. I know here my y value for sure is 200. It looks like my x value is also at 200. So if I plug in 200 here for y, subtract it, I'm left with 100. 50 cents goes into 100, 200 times. So I know I have all 5 of my points. Okay. Now, if you struggle with that, like for this one, if you want to, you can do a matrix. You just have to know that your first point is 0, 1, because you have no x's, 1, y. And then your next equation is 0.51 xy equals, and then you know you have the points 200, 300, and you can do that also. But for time's sake being, I think it's a little bit easier once you have one of the x's, plugging it in and solving for y. So now, plug it into the objective function. Again, our objective function, if I go back up top, I think was 4x plus 7y. Yep. 4x plus 7y. Sorry, it's income, not profit. So on the first one, 4 times 0 plus 7 times 0 is 0. On the next one, 4 times 0 plus 7 times 200 is 1400. The next one, the income, is 4 times 400 plus 7 times 0 is 1600. So we're getting a little bit higher. So the question is, which one of these two is it going to be? 4 times 400 plus 7 times 100. Let's see, 16 and 700 make 23. And then on the last one, 4 times 200 plus 7 times 200. Let's see, that's 1400 and 800. That's only 2200. So our winner is that one right there. So let's write the sentence real quick. We should sell 400 student tickets and 100 general admission tickets for a maximum income of $2,300. Excellent. All right, let's go to the back page here. let's take a look at this one here. It says the Maple Store sells computers and printers. The computers are shipped in 1,200 cubic foot boxes and the printers are shipped in 8 cubic feet boxes. The store has a storeroom that can hold 4,800 cubic feet. The store has a sale goal of at least 100 computers and at least 150 printers that will be sold this month. The computers are sold for a profit of $1,000. Printers are sold for a profit of $350. How many computers and printers should be sold each month to maximize profit? What is that maximum profit? So again, that last sentence tells us, in this case, really, last two sentences, what we want to find and what should be our variables. So X is going to be the number of computers sold. Y is going to equal the number of printers sold. P is going to be our profit. So our objective function, again, is to maximize profit. So max P. So according to our sentence previous to the end, we make $1,000 on each computer and $350 on each printer. So now, what are our constraints? This one's going to be a unique one because we actually don't need to put X greater than 0 and Y greater than 0 because of this sentence. X has to be at least 100 and Y has to be at least 150. So we don't need X being greater than or equal to 0 and Y being greater than or equal to 0 because they actually have to be bigger than 100 and 150 respectively. The last one deals with the size of the boxes and how much storage space we have. So 12 times X plus 8 times Y has to be less than 4,800 cubic feet because it's 12 for every computer plus 8 for every printer has to be less than our 4,800. All right, so now I'm going to actually graph this. Wow, we don't have as much room as I thought here. So I have to start squeezing a little bit here. I'm going to let X equal 0, solve for Y, let Y equal 0 and solve for X. So now I'm going to check to see how many 12s go, or if I let X equal 0, how many 8s go into 4,800, and I believe that's 600. And then if I let Y equal 0, how many 12s? That's 400. So if I look at my constraints, 100, 150, and I can go up to 600. So I think I'm still going to try to count by 100s here. So here's my computers. And here are my printers. So if I scale this, let's go to brown here. 100, 200, 300, 400, 500, 600. Do the same thing. 1, 2, 3, 4, 5, 6. Thought about counting by 50s, but 650 goes into 612 times, so it'd be off the grid just a little bit. So now 0, 600, and then 400, 0. Oops. Show up nicely here. So if I connect those two, my inequality is going to be going less than. Then I have to graph the other two. X has to be greater than or equal to 100. So that's a vertical line, but it's a greater than, so I'm going in this direction. And then the other one, Y has to be greater than or equal to 150. Graph this one. It's got to be greater than, so my feasible region ends up being this triangle. So I have 1, 2, 3 corner points I need to actually figure out. So I'm actually going to write the corner points here, since I don't have a lot of space written here. So probably the easiest corner point is right here, because we know that x is 100 and y is 150. So we have 100 and 150. Now finding the rest of them is going to take a little bit more work. Okay? So on this one right here, I know that x is 100. Okay? So if I plug 100 right here, I'll have 1200 plus 8y has to be less than or equal, or has to equal 4800, since it has to go into that one. So if I subtract, 8y has to equal 4800. So if I divide by 8, 4800 divided by 8, gives me, well, not 4800, I didn't subtract right. That should have been 3600. My fault, because I have to subtract the 1200. My fault, Mr. Bartz. I was going to say something didn't seem right. Clear that up. 3600 divided by 8 tells me I could sell 450 of them. So, and I look at that graph, and does that seem to be about right? Okay, mine was a little bit high, partially because my line was a little bit low. But that intersection point should be actually sitting at about right there. Okay. Then I do my other one. Here, I know, if I take a look here, my y is 150. So if I take and plug it into here, I'll have 12x plus 8 times 150. That has to equal 4800. So 12x, 8 times 150 is actually another 1200. So if I subtract 12x equals 3600, divide by 12, then x equals 300. And that actually looks pretty good. So at least the line looks better there. So now I need to plug each of these into my objective function. So when I plug in the first point, my profit would be 1000 times 100 plus 350 times 150. Wow. So let's do that. 1000 times 100 plus 350 times, it was 150. So that gives me 152,500. On the next one, it'll be 1,000. Oops. So it'd be 1,000 times 100 plus 350 times 450. So plug that into our calculator. It's actually the same thing, except I changed this 150 to 450. So we know that this one's going to be at least bigger. 257,500. And then our last one would be 1,000 times 300 plus 350 times 150. I'm thinking this one's going to be the winner. So 1,000 times 300 plus 350 times 150. 352.50. So that's our solution here. So to write the quick sentence, I'm actually going to write it up top here. So we should make 300 computers and 150 printers to maximize our profit of $352,500. All right, excellent. The last one we've really actually not talked about, so hopefully in class I tell you to cross that one out of your homework assignment. So with that being said, we are finished with this video.